Without magnetism, many things we take for granted today would not exist. With the advancement of technology, we are using magnetism or many instruments with magnets to make our daily life easier. Here are some examples of using magnets in various purposes. You can see here MRI machines, electric motors, magnetic cards, and crane used to remove large amount of scrap iron. There are two main types of magnet as electromagnets and permanent magnet. Here you can see in electromagnet, magnetism exists only while a current is passing through it. But in permanent magnet, magnetism remains permanently. Then what is meant by magnetism? Magnetism is the power or a force exerted by magnets. Before scientists discovered how it worked, it was thought to be a magical power. In previous classes, you learned about this force or ability as attraction and repulsion. I hope that you are doing more activities to identify this ability by closing a magnet to different types of things. Here is an activity. Can you categorize the things shown in the screen as things which are not attracted to a magnet and things are attracted to magnet? You can get answers as objects made of magnetic material such as iron, steel, nickel are attracted by magnets here. But objects made of such as plastic, wood, papers, rubber are not attracted by magnets. Now let's engage in another activity. You can see that there is a magnet on my hand and there are some pins on the table. The magnet is keeping above of the pins with a gap and there is no any observation. Can you see? Yes. When the magnet is closer gradually to pins, you can observe how the pins reacted, and when it more closer, the pins get attracted to magnet instantly. As you observe, when we reduce the gap between the magnet and the pins to a certain level, the magnet can attract them. The best known use for magnet is in compasses. The compass was invented by Chinese in the 11th century. Compass needle always point to the north. But why? The answer was found by William Gilbert, an English scientist. He discovered that a compass needle is in fact a magnet, and the Earth itself has a magnetic field, with one magnetic pole near the North Pole and the other near the South Pole. Here, look at the image on the Earth on the screen. You can get the idea. North Pole lines of a small bar magnet in compass up with the Earth magnetic field, showing us where North is. When a compass is placed at a point in a region where the magnetic field exists, the direction of the compass needle shows the direction of the magnetic field. That is how we identify the direction by using a compass. I hope that you have an idea about magnetic field. The field is strongest in two places on the magnet. We called it North Pole and South Pole. On a bar-shaped magnet, the poles are at either end. The magnetic field in vicinity of magnets given here. Vicinity means around, nearby. Then what is magnetic field? The region around any magnet where the magnetism spread is known as magnetic field. These lines are drawn to represent the magnetic field. Here are some examples of magnetic fields: field of bar magnet and a U-shaped magnet. The magnitude of the magnetic field changes with the magnetic property of the magnet. If you scatter tiny iron filings around a magnet, they line up along the lines of magnetic force around the magnet. Here there is a bar magnet and tiny iron filings. More filings collect at the poles than anywhere else. I told you earlier, the strength of the magnetic field varies from point to point. Now you can see iron filings collected at the end of bar magnet. A compass needle will also point along the lines of magnetic force. The direction of the compass varies from point to point. Therefore, magnetic field is a physical quantity with a magnitude and a definite direction. It's a vector quantity. The arrows are drawn to represent the north to south direction of magnetic field. Not only in permanent magnet, we discuss up to here about permanent magnets and its behavior, but also in electromagnets has the magnetic field around it. Let's pay more attention about it. There are strong connection between electricity and magnetism. Here, there is a picture of Danish scientist Hans Christian Ørsted. This was first noticed in 1820. Danish scientist Hans Christian Ørsted, he saw that a current flowing through a wire made a nearby compass needle move. Later, Andrew Ampere in France discovered that electric current in wires can attract or repel each other just like magnets. Today, these principles are used to make a powerful type of magnet called an electromagnet. As I told earlier, there are strong connection between electricity and magnetism. An electromagnet is made by passing an electric current through a coil of wire. When the current is switched off, the electromagnet loses its magnetism. Electromagnet used in many electrical machines. Let's discuss further by our next video on electromagnetism.